Now for this problem, there is a block and it's resting on a tabletop. The block has a mass of 10 kilograms. And what we want to know is what is the force that the table is exerting onto the block? Our first step is always to identify. So we're actually looking for the force of the table. So we'll give that a F of t. And that will equal, say, a question mark. We may want to label a positive and a minus direction. So we'll go ahead and we'll give this a positive direction for our coordinate system. We can also note maybe the mass of the block, since that is given to us, of 10 kilograms. And we also need to identify an equation that relates all of these variables together. So what we're going to use is one of Newton's laws, which is going to be F net equals ma. Now before we actually execute this, we can also identify that the block and the table are actually not even moving. So that means we have an acceleration of 0. So let's go ahead and set up our problem for the next step. We have again F net, so we have the force of the table plus the force of the block is equal to ma. But for this example, we already know that m is given to us, but a is 0 since it's not moving. So as we continue to solve this and set up the problem, we'll have f of t is equal to a minus f of b. So this leads us to our next problem. What is actually f of b? Well, the only force that the block is experiencing is the force of gravity itself. So we can go ahead and start the next step, which is actually an E for execute. So we'll go ahead and put E. So continuing with the problem, we have f of b is equal to ma. But the a that we're using is the acceleration of gravity. So we get this here, mg. But we also have to note that since we indicated up was a positive direction and gravity is going to be pulling down, gravity is actually negative. So that will equal negative mg instead of positive mg. So as we plug that in back to our equation here that we found down here, that f of t is equal to a negative f of b, and f of b is equal to the negative mg, that will indicate a positive 100 newtons, which is in the up direction that we labeled before. Now as we go ahead to our next step to actually evaluate the answer, we got an answer of 100 newtons pointing in the up direction, and that checks out. And we also get Newton's third law, that these forces are opposite and equal to each other. So if we just look at the magnitudes themselves, they are pretty much the same force, which we found down here. F of t is equal to negative f of b. So that makes sense as well. So remember, although there was no acceleration in this problem, there are still forces that are acting upon the block and the table itself.